Hi again, AP Calcers. Getting toward the end of this first unit already, and today we're going to talk about derivatives of the inverse trig functions. Now, just to refresh your memory a little bit what we mean by inverse trig functions, according to your circle chart you can see where this is true, that the sine of 30 degrees is 1/2. All those ordered pairs around there relate to an x and a y value, and of course x stands for cosine and y for sine. So the sine of 30 is 1/2. Now what the inverse trig functions do is essentially just reverse the x and y, or the domain and range. So now we say the inverse sine of 1/2 equals 30, just reversing the domain and range from this example. Now, you may remember using this inverse sine primarily in pre-calculus to maybe find the missing angle of some triangle that was given to you, that type of thing. Now, we can actually graph an inverse function, so I did that here so you can see what that looks like. It's only just a tiny portion of the graph, and if you think back long and hard from your pre-calc days, the reason this is such a diminutive graph is we had to restrict the domains and ranges of this inverse sine function in order for it to be called a function, for it to pass this vertical line test. So anyway, that's just a bit of background for the inverse trig functions. The next slide you'll probably just want to pause for a while, which I'll show to you right now. And this just has all of the formulas for the inverse trig function derivatives. And this looks kind of bad, but when we do a couple examples, I think you'll find that it's maybe one of the easier things we have done. It's kind of beyond the scope of this class to do any proofs of these things, but make sure to write all these down. Notice they all look sort of the same. Now the idea here, this u, of course, most of the time it would be some function of x or t or something like that. But here's the key thing that often is forgotten, this du over dx. So this is our chain rule once again, that if you have some particular function, we apply the main formula to it, but then we cannot forget to multiply by the derivative of that main function, and that's our chain rule coming back into play here. So take some time and write all these down carefully, even though they all are on your Spark chart. It's good to write these down so you can get a feel for how they work. And then the next slide we're going to do just a couple different examples. Alright, here we go. Here's our first couple examples. Directions here: find the derivative of y with respect to the appropriate variable. So for instance, in this case we're going to find dy over dx. Now if we just apply that inverse trig derivative, we see that it's going to be 1 over, and then almost all these have a square root, 1 minus for the trig function here, and then whatever the function is, we basically have to square that. So 3x squared, and then here's the tricky part: you now have to multiply by the derivative of this argument, or of that function, and of course the derivative of 3x is just 3. That goes in the numerator. And so oftentimes we can simplify this a little bit. Our numerator will be just plain 3. Our denominator will still have that square root in it, but it's going to be 1 minus 3x times 3x is actually 9x squared. So that's really the best we can do for that. That's the derivative of our first function there. Alright, let's take a look at the second one and see what that gives us here. This one's a little bit trickier. Once again, here's that square root of t, and remember that square root of t, we can often write that, is somewhat helpful anyway, to write that as t to the 1/2 power. Now in this case it might not be that helpful to do it right away, although later on when we have to find that derivative it'll be kind of nice. So here we go. In this case it's going to be dy over dt. And just applying that formula that we saw there, notice that there is a negative sign. It's going to be 1 over 1 plus whatever this thing is squared. Now I think in this case it's good just to keep it as the square root of t squared. and then don't forget we have to multiply by the derivative. Now, what is the derivative of the square root of t? Well, once again, if you remember, we have to take 1/2 times t to the negative 1/2. That's how you find the derivative with any kind of power. It's kind of goofy when we have fractions like that, but that's the deal. And it might be nice to write this, well, let's see, I think I'm going to just leave it like that. So I just know I need to multiply it by this, I'm going to say. So now as I continue to write this, so still have my negative sign, 1 over 1 plus, now what is the square root of t squared? Well, that's just going to be plain old t, so that's kind of nice. Now, here's where it gets a little tricky. Notice the derivative, part of my chain rule thing, I can actually write this as 1 over 2, and then because it's t to the negative 1/2, I have to write that square root of t in the denominator like that. Now, there's nothing to say that you can't just leave it like this. That's equivalent to this, but oftentimes it's nicer to clean it up a little bit and not have those negative exponents. So this is essentially it. We could probably, again, clean this up a little bit and write it as -1. That's the only thing that's in my numerator. I may put that 2 times the square root of t out front like this, just to show that I do have to multiply all of that by the other 1 plus t. So there's my answer there. A bit of a pain, and the algebra gets a bit gunky, but really this is just kind of plugging and chugging into various formulas in its essence here. So that's what finding derivatives of inverse trig functions are all about. We'll be working on this in class, so we'll see you guys then.